Okay, in this lesson, you are trading your car, but a car dealer claims that the mean price of the make and year of your car is no more than $11,000. You suspect that this value is too low, and you find a random sample of 14 similar vehicles that has a mean price of $11,500 and a standard deviation of 785. Is there enough evidence to reject the dealer's claim at a 5% confidence or significance level? Okay, so this is a little tricky in terms of deciding what kind of test we have going on here. We know that our null hypothesis, we are testing the mean is equal to $11,000 because that's the dealer's claim that it's equal to $11,000. But you think he is low, therefore you think the mean is higher than 11,000. So our alternate hypothesis is that the mean is greater than 11,000. And because this is a greater than sign here, we know that this is a right-tailed test. So our confidence level is 95%. Our alpha is 0.05. We got that from that last statement here. Our n, our sample size is 14. Our degree of freedom is 13, one less than the sample size. Our critical value is 1.771, and I got that from the t-table. So let me go to that. We're going to look at the first column. We're going to be looking for the degree of freedom for 13, and we're in a 5% one-tailed test. So I come to this, and I've got my second. I'm going to follow the second line row over to 0.05. The second row is for one-tailed probability, and we want 5% in a tail, and we're going to go all the way down to 13, the row 13, where that intersects here is at 1.771. Now we're going to be using the positive because this is going to be a right-tailed test, which is going to be on the right side of the slope with positive signs. So back to our problem here. Our test statistic, we're going to be using our formula where we take the sample mean minus what we're testing the population mean to be, and divide by the standard deviation of our sample divided by the square root of the sample size. So we can plug all that in. We would calculate this out to get test statistic, a t-score of 2.383, and that is pretty darn high, definitely much higher than 1.771. So we know that just from there, it's higher, we're probably going to be rejecting. But I've got a statement here that this value is between 0.025 and 0.1 on table 5, or the table. So I'm going to go back and show you that. So I'm going back to our row 13, and I'm comparing to 1.771, and we had 2.38 would be right in here between these two columns, the middle column and the fourth column. And when I follow those up to the one-tailed probability, that's going to be between 2.5% and 1%, or I should say 1% up to 2.5%. Definitely, much less than 5%. So that's what I'm referring to there. And if you did not have StatCrunch, you would have to go to this table to try to decide where your t-score was falling. You'd get a general range for the p-value, but you would not get the exact p-value. So I'm going back to our problem. So when I do all three of my methods, when I'm drawing the curve for the critical value method, again, very similar to the normal curve, I draw in here my critical value. That marks the beginning of my rejection zone. Rejection zone is to the right. 2.383 is in that rejection zone, so that's going to give us evidence that we could go ahead and reject the null hypothesis. When I do the p-value in StatCrunch, I come up with this value here, 0.0166. And I might as well go ahead and show you how to do that. When I go into StatCrunch, I'm going to go to Stats, T-Statistics, One Sample with Summary. Okay, I need to put in the mean for my situation here. I had 11,500 was the mean value of my sample of car values. The standard deviation for my sample was 785, and my sample size was 14. So I'm putting in my sample information here. I'm going to be doing a hypothesis test, and we're checking, again, the dealer claims that the value of your make and year of car is 11,000, so that's what we're testing here. I'm going to drop down menu, and I am going to assume greater than, because we feel our alternative is that the car value is greater than 11,000. So I go to click compute, and I come up with the same test statistic, and I do get that exact, well, the z-score of 0.01 0.66. I guess that's all depending upon which technology you use as to how exact we want to be. But that p-value is definitely much less than our 0.05, which is going to, the p-value is low, the null must go. While I'm in here, I'm going to go ahead and do the confidence interval. So I come down and I click on the confidence interval. It defaults to 0.95, but remember I did a 95% confidence level test on a right tail test. So in that case I had to have 5% or 5% alpha in my right tail. The confidence interval that is going to have 5 alpha in each tail, and the right tail included, is going to be the 90% confidence level. So I need to change this to 0.9 for the confidence interval. Confidence intervals are two-tailed events. I need to choose a confidence interval that is going to have 5 in both tails. So I click compute and I end up with a lower limit of 11,128 and upper limit of 11,871. So let's go back here. When we plugged in and used our formula and did this by hand, we came up with the same thing. And we are finding that we have a lower limit. The mu must be between this lower limit and this upper limit. When we think about this, the dealer is claiming that the car value, the mean of your car is, car values is 11,000. Well, that 11,000 isn't even in this confidence interval. And this is a 90% confidence interval. We're 90% confident that the true value of the true mean value would be in this confidence level. So that again is more evidence. All three of these will support the decision to reject the null hypothesis. There is sufficient evidence that the value of your car is greater than 11,000.